delighted to. I always feel slightly, my guest at 10 o'clock is always the speaker when the meetings start and half of the audience gets started. I promise it's not you, okay? That's the event. So please put your hands together and welcome Aymeric Denoeud from Michelin Resicare.
So perfect, thank you. So someone need to kickstart the thing, so it had to be me. I'm here to talk to you about a chicken and egg problem today, and specifically about one very interesting bioblock, which is the 5-HMF. So my name is Aymeric Denoeud, and I'm a Chief Revenue Officer of Michelin Resicare. I'm glad that I've heard the name of Michelin twice in the previous conversations, which shows that Michelin is really pioneering in the world of bio-based materials. But before, if we keep, all right, there we go. So we're talking about 5-HMF. 5-HMF, 5-hydroxyl-methylfurfural. What is interesting about this monomer that you're seeing here is it ticks two boxes, the safe box and the sustainable box. And actually, you've eaten 5-HMF. If you've done some caramel at home or you've eaten some honey, you would have had some 5-HMF. So this is a bio-based monomer, really interesting for that reason. In our case, that comes from fructose syrup. That would come from either corn or sugar beet, for example. So that's the first one. The second one, this is a monomer which is low carbon, especially when you design a process from scratch, which is made to be low carbon, using low carbon energy, recycling solvents, recycling water. That's the second one. And last but not least, it's a monomer which doesn't meet the CMR, so carcinogenic, mutagenic criteria. And we actually the lead registrant in Europe for that, so we're carrying out all the tests to make sure this is not the case. So that's why that is 5-HMF. And why 5-HMF? Well, you can see in chemically, and I'm not a chemist, but what's interesting is that you got, in the monomer, you got an aromatic cycle, you got an aldehyde function, and an alcohol function. And for that reason, that makes it very versatile. So, click. So, first reason is like you can use it in a lot of different places. So that could be used directly as a molecule in adhesives, surfactants, flavors, but also a lot of different other fields. That's one side of it. And the second side is it's also a precursor of a lot of derivatives, such as diacids like FDCA, diols like BHMF, or dialdehydes like DFF or BMF. So you can see it's a really interesting monomer for a lot of different things, whether you use it directly or indirectly. And what happened with 5-HMF over the last 15 years is that there's been a lot of research around it. So that's the amount of patents that have been filed mentioning 5-HMF. So you can see it's been increasing a lot. A lot of people are looking at it. But and that's one of the reasons why it's been called a giant. A really interesting bioblock. But it's also been called a sleeping giant. Sleeping giant, why? Because simply there's no supply chain for it at the moment. It's very limited, so you can do some research, but you can't necessarily get access to it. But before I get into this, you might wonder, say, why Michelin Resicare talking about it? So the whole story started in 2004, when the EU implemented a new directive about carcinogenic products, saying that you need to reduce the exposure of your people to carcinogenic products, such as formaldehyde. And formaldehyde is one of the products that we're using in tires. And so Michelin asked the researcher in the lab to find alternatives to resorcinol formaldehyde glues that we find normally in your tires. And we found something in 2008. That is actually the beginning of the story with our little molecule, with the glues. So since then, we've been rolling it out, that technology, in tires. But at the same time, in 2016, Michelin realized that the value of what we found, of those resins, is a lot bigger than just what we're using in the tires, and only a couple of drops. And for the last few years, we've developing a number of resin glues in a number of fields, such as like bio-based wood panels, but also composite panels, and a lot of other fields, friction, insulation, using what we'd found initially, and using 5HMF. So like we are a big user, we're pushing that the technology of the resin in general that we call aramidinolic, but that's based on 5HMF. And typically we've just reached 100 million mark of number of tires being produced using the technology just very recently. But I'm going back to my chicken and egg dilemma. So you might be doing some research of 5HMF, but if you don't have the supply, you're a bit of stuck, right? You're gonna stop early on in a development. And at the same time, if you want to develop some supply, you can't if you don't have some usage and some people pulling. And that had to be solved. Otherwise, we're stopping at that research, early research, and nothing else. And that's what we're announcing today. It's been announced in the press a couple of weeks ago, but actually Michelin, nope, the one before. We just announced the construction of the first 5HMF unit in Europe, and this is actually an actual 3-year representation of what it would look like, and that's coming in 2026. It's coming in 2026 in France, and just before we talked about security of supply, so that's one of the important points. Fabien from L'Oréal was mentioning it. So built in the south of Lyon, so that'll be the first HMF production unit in Europe. It's a 60 million investment that will allow us to reach 3,000 and hopefully more tons per year, with behind the idea of developing the supply chain to go up to 40,000 tons in the future. So with this investment, we're unlocking the first part, the supply part. And it's a big step forward for Michelin, but it's also a step that's necessary for the entire industry. Someone has to do that first step. So that's on the supply side. If we go next on the usage side, we're also working on it. And we've developed a consortium of partners with universities, companies, so Creighton, Avancium, ADM, I think some of them are around here, Arkema as well, to unlock the previous research and what they've done until now with 5HMF, and to really push that level of research to the face of usage. And actually, we are supported by the ADEME in France, but also more importantly and more recently, we've been awarded, actually the unit has been awarded the flagship from the Circular Biobased Europe. And actually the consortium just got granted like 20 million euros to develop the project, which shows how important it is for us, Michelin, but also how important for Europe. So what's next from this? And why could you be interested here in the room? What we're hoping is, if you've done some research in the past, some existing research, you have something going on right now, or you've done some research in the past, and talking to different partners, we found that they've done some research in the past, but stopped. Now with an access, with the supply side being unlocked, you can get access to 5HMF. So you can carry on doing your research and go to the next stage of development. So that's one thing. You can also explore the 5HMF derivatives. We found a lot of partners really interested in this. Why is that? Because a diol, a diacids, dihaldehydes, they're all very interesting, easy to plug in an existing product. So we might not necessarily do them ourselves, but in the consortium, we have people working on it, so we can connect you with the right people. And last not but least, but we're all preparing the future. So we're inviting people to innovate with a new bioblog. And this the fields we've identified where they might be interesting is like thermoset resins, chemical derivatives, polyesters, coatings, surfactants, flavors, animal feed. All of those, we know 5HMF can have a role to play. So here it is for us today. We are obviously will be in the room today, so we're only going to be here today, but we'll be glad to meet you, either myself or Paul, my colleague here, and hopefully we can talk about the potential of 5HMF. Thank you very much.